Students, welcome to Unit 6, Quads and Polygons, the last section, Lesson 6.6, Coordinate Motion. Coordinate motion. You're looking at this last section of your preview notes. Make sure you get a time and location here, and a parent, guardian, or teacher sign-off. We're going to do a quick review here. We're going to finger track and read this out loud. You're going to highlight, underline keywords. You're going to draw. You're going to label your drawing. You're going to list your given information. First off, the shape you're working with here, I'd like you to trace it. That is a trapezoid. Now, I'd like you to read this problem, solve on your own, and then restart the video. Pause. Okay, welcome back. Let's see what you should have done. It says, if a dam has a median of 360 feet, so median would be middle, so the midpoint, both sides, and it's 360 feet, and it says the top of the dam is 3 times greater than the bottom of the dam. We have a 3x and x relationship. Find the top and bottom of the dam. Let's pull this out so it's easy to see. There's your median. And the top is 3 of something, and your bottom is something. So we're going to start by writing out the equation for median, which is median equals base plus base over 2. Then you circle, plug, chug. You always write your equations, 2 sides with an equal sign. So that's 360 equals. We're going to put this over 1. You should have gotten 3x. 360 equals 4x divided by 2. You can actually simplify this. So we have 360 equals 2x. Therefore, your x, which is the bottom of your base, should have been 180. And your top should be 3 times that, which is 540. And then here's your check. You do 540 plus 180. And that's going to be 720 divided by 2, 360, check, and then over. So that's from the last class. Now what we learned, we're starting motions on a coordinate plane, motions on a coordinate plane. In last class, we studied just the one motion of dilation. That's the change in size multiplied. 3 other motions. Translation, which is applied, reflection, where you flip, and then rotation. The concept of K-factor, you were introduced last time, and then counterclockwise. You're familiar with this. Clockwise is to the right, counterclockwise is to the left. Let's start with the simplest of this, and this is translation. Translation. Let me give you the math, and then we'll do translation means you slide. So you start with a point. Then you have horizontal motion. We'll call H for horizontal and V for vertical. And then what you do is you simply add the horizontal motion to the X. And you add the vertical motion to the Y. So you have X, Y, you move by horizontal. So you simply add the horizontal to this. Sounds like translation. 2 side, add to the left, add to the right. 2 side, add to the left, add to the right. Oh, of course, going on here. Okay, so let's take a shot at this one. There's 2 ways to do this. So step number 1, let's get our coordinates. And so just do those own coordinates. You can do them as fast as I can. Just So it says we're going to take this triangle ABC, we're going to translate, and remember translate just means we're sliding it around, 6 units left, that means we're going to do -6 for our horizontal, 2 units down, so we're going this way down, so that's technically that's -2. So let's use little arrows to help you envision it. I'm going to show you the mathematical way, and then I'll show you the shortcut way. Mathematical, this is what programmers have to do. So to all the x's, you are going to -6. So just do a little arrow, -6, all the x's. That's the horizontal. So 4 -6, that's -2. 7 -6, +1. 2 -6, -4. And then your vertical motion is going to be -2. So I'm going to go this way, -2. So 3 -2, that's 1. -1 -2, -3, -4. So your new coordinates are right there. Let's plot these 3 new coordinates. And that's now A prime. B prime. C prime. And you close it up, you should have the exact same shape, it's just slid. Now that's how the programmers have to do it. They have to do it mathematically because they're working in a non-physical world. But for us, there's actually a little bit shortcut. 6 units to the left, you can start with your original, just bunny hop it 6 units to the left. 4, 5, 6, and 2 units down. 1, 2, bam, you got the same thing. So you can use that shortcut if you have a physical world to exist in, but programmers have to use the to slide, add to the left, add to the right. That's translation. Now we have the 2 what I call easy peasies. Reflection. We're going to reflect over the y-axis. So go ahead and darken the y-axis. Get in the habit of just predicting where your shape's going to go. If we're going to flip over the y-axis, technically we're going to go like that. Do you see it? Just draw. So we're going to end up somewhere over here. And if you look closely, the motion we're actually engaging in is a horizontal motion. So if you have xy, to flip over the y-axis, you simply opposite the x-coordinate. Why? Because technically it's a horizontal motion. So when I say opposite, notice I add a minus sign, negative sign. So our little chant here is this. To flip over the y, opposite the x. To flip over the y, opposite the x. Right with me. To flip over the y, opposite the x. So let's get our coordinates here again. Same coordinates every time to make it easy. So to flip over the y, we simply opposite that x coordinate. So this is going to be negative 4, 3, negative 7, -1, -2, -2. So we just opposite that x coordinate. Let's plot that. Close it up, and you should have a mirrored image directly over the y-axis, if you've seen this correctly, a mirrored image. To flip over the y, you opposite the x. This one, we're going to flip over the x-axis. So now we're going this way. We're flipping over that line. And always get in the habit of drawing some sort of arrow to figure out, predict where you're going to go. Just very lightly, if we flip over this red line, we know our shape's going to go this way. So we have x, y. And to flip over the x-axis, we simply opposite the y coordinate now. Why is it the y coordinate? You can see your motion this time is now a vertical motion. I didn't really label ABC. I'm just going to work left to right. So we're going to make that A. B. And C. And it goes like this. To flip over the x, opposite the y. To flip over the x, opposite the y. So we're simply going to opposite this y coordinate. And if it's already negative, the opposite would then be positive. So we just did the opposite right here in the y coordinate. Now plot those 3 points. And if you've done this correctly, again, the exact same image, except it's mirrored, or think of it as a butterfly over the x-axis. Once again, to flip over the x, you opposite the y. So that's your reflection. So now we have 2 under our belt. Translation, reflection. Now, rotations are probably the trickiest, so you got to pay very close attention here. There's 3 different rotations, 90 clockwise, 90 counter, and then 180. To rotate 90 clockwise, you start XY. It's actually, I'm going to read this. To rotate 90 clockwise, switch and flip to the right. That's how that reads. To rotate 90 clockwise, switch and flip to the right. One more time. To rotate 90 clockwise, switch and flip to the right. So you switch first. So that's going to be YX. And then you flip the sign to the right only. Notice it's a clockwise arrow, so we're going to opposite to the right. That won't make a whole lot of sense until we actually do this. Let me show you what I mean. Let's get our 3 coordinates first, the same 3 that we've been working with. Start writing those coordinates down for A. Okay, so that is 4, 3, 7, -1, 2, -2. Okay, to rotate 90 clockwise. Remember, you draw a little line predicting which way we're going. Clockwise means to the right, so we're going to be rotating 90 degrees. Just draw a little arrow. We're heading that direction. Okay, step 1. Do this in 2 steps, not 1. It's switch, then flip. Do not do this in 2 steps. Do not do this in 1 step. Do it in 2 steps. Step 1, we just switch. So 4, 3 becomes 3, 4. You see what we just did? We switched. Now we flip the sign, and because it's clockwise, we draw a clockwise arrow, flip the sign. Clockwise arrow, flip the sign. Clockwise arrow, flip the sign. Now we're going to graph those 3 new points. So sub A, sub B, sub C. Close it up. And let me bring this in. A little hard to see if this really rotated the way you want it. Let me show you a trick so you can know that you did this correctly. So this is called rotating from the origin. So at the origin, put it on. Now you connect any two of the pre and subpoints. I'm going to use A. So draw a line to A, the original A. I'll go back to the origin. And now draw another line to sub A, or prime A. Now look very carefully. Those 2 points, does it look like 90 degrees? Yeah. And then you look at which direction you went. You went clockwise. So we actually did rotate clockwise 90 degrees. So choose any 2 sets of points, and that'll help confirm you did that correctly. Okay, so once again, to rotate 90 clockwise, we can flip to the right. Now counterclockwise. To rotate 90 counterclockwise, switch and flip to the left now. So first you switch. Draw a counterclockwise arrow, flip the sign. The chant goes like this. Rotate 90 counterclockwise, switch and flip to the left. To rotate 90 counterclockwise, to the left. Let's actually do this here. So get those 3 points, same 3 points we've been using. And we draw a little arrow which way we're going here. We're going counterclockwise 90 degrees. So just right here, we're going that direction. See that yellow? That's the direction we're headed. Like do a little predictive arrow. Kind of tell your brain we're going to go this way. So now we switch and flip to the left. We do that in 2 steps. Step number 1, just switch. So 4, 3 becomes 3, 4. We just switch. Now we draw a counterclockwise arrow, flip the sign just on that one direction. If it starts negative, it becomes positive. Now we're going to graph those 3 points. That was A. Close it up. Let me shrink this down so we can see it, or zoom in. Once again, it's a little hard to see if this was actually correct. So we're going to choose any 2 points here Start at the origin. I'm going to use C this time, just for kicks. Okay, so from the origin, draw a line to your first C. From the origin, draw your line to C prime. And if you look at that really carefully, that should be 90 degrees. And if you look at the motion, it was counterclockwise. Okay. So that's rotate 90, counterclockwise, switch and flip to the left. Last motion, and one of the easiest. It's called reflection over the origin or rotate 180. Why is there an and here? I want you to see that this is honestly the same thing. Let me show you. Ready? Okay, so just draw this very lightly. If we take this, and if we rotate it 180 degrees, you can see you're going to end up right over here somewhere. Right? 180. And then here's your origin. If we flip through the origin, do you see you're going to end up right at the same place? So flipping over the origin and rotating 180 is exactly the same thing. Make sure you understand that. So to reflect over the origin or rotate 180, which is the same thing, all you do is you opposite both coordinates. So to flip over the origin, opposite both. To flip over the origin, opposite both. Flip over the origin. Remember, flipping over the origin and rotate 180 is exactly the same. So the same three coordinates we've been working with here. And if we're going to flip over the origin, you simply opposite both coordinates. That's going to be -4, -3. This is -7, and of course that negative becomes a +1. This is -2, and that negative becomes a +2. Go ahead and plot those. Close it up. And you can see the easiest way to make sure you did this correctly is just take 2 points, and you should be able to draw an exact 180 degrees between them. Or, so C, that shows 180. Or another way you can check it is just connect any of the 2 lines, and they should go straight through the origin. Look at A. See A prime. It should flip over right through the origin. Either way, rotate 180. Flip over the origin is exactly the same thing. So just keep in mind, so reflect over the origin and rotate by 180 is the same thing. Last one we did this in class is dilation. It's to change in size, you multiply. So this one's a little bit of a review. So to change in size, you multiply. So if you have xy and you dilate by factor k, it's simply x times k, comma, y times k. And you guys already know if you k factor is bigger than 1, it gets larger, less than 1, it gets smaller. So let's go ahead and dilate this one together, and then you're going to do one on your own. Let's get those coordinates. A is sitting at, what is that? At 9, 9? And then B. And we're going to dilate by 5/3. 5/3 is bigger than 1, so right off the bat, we know we're going to end up with a larger image. So right here, I'm going to split up my 9s. I'm timesing them both by 5/3. We're going to do arrow in, arrow out. 3 goes into 9 3 times. Bring that around. 3 times 5, 15. If you remember how to do this in class, just keep cranking away on your own. When you're done, plot your 3 points, connect them. You should end up with the exact same image, but just smaller. So we have 15, 15. Want to help me out of this so I can not keep scrolling back to see. Is 15, 15? Okay, there's 15, 15. And then 10, 15? 10, oops, back up, 15. And 15, 10. 15. And when you close it up, again, the exact same shape, but it's obviously larger than this one, which makes sense because it's 5/3. All right, this last one, you're going to dilate that one completely on your own. Whoops, I think we already did that one. We just did it on a small scale. Yep, we already did it. It's not in here. Well, okay then. You are done.